Okay, to go over the next part of this lesson, let's look at um, how do you do it if there's more than two fractions in solving. Now, we're still going to look at restrictions because what makes the denominator 0 can't be a solution. But when you want to look at more than two fractions, then proportions is not going to work. And you're going to need to look at getting a common denominator in a little bit different way. One of the things you want to really do is you really don't want to work with fractions. So we're going to do a method called find the least common denominator, but instead of getting the common denominator on each problem, you're going to multiply by the common denominator. Now, to begin with, I have this one denominator, so that tells me x cannot be equal to 0. So when I get done, if x is equal to 0 in my solving process, then I'm going to definitely want to say there's no solution. But as long as I get any number but 0, it's the solution. And then over here, we're going to talk about what's the least common denominator. Well, I think it's going to be 10x because I can change the 5 to a 10. I can put a 10 on the first one, and then I can make sure they all have an x. So instead of changing it to do that, what you do is you do 10x times each one. Let's try that again. So I'm just doing the common denominator times each one. And what this does is it gets rid of the denominator, which is why you want to check your restrictions at the beginning, because the denominators go away. So now these two cancel, giving me 60. 5 goes into 10 two times. That makes that multiply out to be negative 14x squared. And on the other side, the 10s cancel, giving me x squared. Now, I probably want to take it so that the x squares are on the other side. So if I add 14 over to the other side, I'll get 15x squared. There's a couple of ways I can solve that, but I'm just going to make it equal to 0 because that's just easier. But that's not always what you need to do. So 15x squared minus 4 does work. If that had not worked, I would have divided by 15 and square rooted it, which would give me the same answer. So x minus 2 and x plus 2 is my factorization. So x can be equal to 2 and negative 2. And those are my solutions, and they have nothing to do with the restriction of x is not equal to 0, so they are both the solutions. Let's try this again with finding the common denominator. So I see that I have two totally different denominators. So 2x plus 5 is equal to 0 makes 2x equal to negative 5, or x cannot be negative 5 halves. And 3x equals 0 means x cannot be 0. So those are my two restrictions. The common denominator, or least common denominator for this problem, is going to have both items, a 3x and a 2x plus 5. So first I'm going to multiply both of these times each one. So 3x, 2x plus 5 is going to get multiplied times the first fraction. And 1 times 3x times 2x plus 5 on the second one. And then 3x and 2x plus 5 times the third one. So now let's see what cancels. Well, here these two cancel, so I just need to distribute 3x, and that'll make 21x squared plus 3x. In the second one, 1 times anything stays the same, so I'm distributing 3x. So again, I get 6x squared plus 15x, simple, easy, distributive. And then over here, the x plus 3's cancel, so you need to FOIL this out. So first times first will be 20x squared. Outer two terms are going to make negative 6x. Inner two terms are going to make 50x. Last term's going to make negative 15. So I got stuff on both sides, and so I'm not really sure what way that would be the best to work with, so I might want to put my terms together some first. So 27x squared on this side plus 18x is going to be equal to 20x squared plus 44x minus 15 on this side. So now that I see that, I think I'm going to bring it all to the left and go minus 20x squared from both sides, minus the 44x from both sides, and add the 15 constant to both sides. That'll make my problem 7x squared. 44 minus 18 is going to be 26, and that'll be negative, and then the plus 15. Now, I don't know if that factors or not, but it's got some possibilities. So 7 times 15 is 105. So 1 times 105. 5 times 21. 3 times, goes 3 times with 1 left over, 35. And that's probably all my choices. It's got to be 2 negatives, so that's this one, because it's got 2 negatives. Add up to negative 26. So then I fill those in and do the whole 5-step method, because I can't do that in my head. It starts with a 7. So if I split the problem, I can only take out an x. If I take out a negative 3, I'll have 7x minus 5 left. And that means 7x minus 5 is 1 in my parentheses and x minus 3. Now when I set that equal to 0, x is going to be 5 over 7 and x is going to be 3. What were my restrictions? Well, my restriction was negative 5 halves and 0. I didn't get negative 5 halves and zeros, so that's my 2 solutions. So in our next problem, looks like we need to factor this one. And I see it has the same thing as the other 2. So x cannot be equal to 0, and x cannot be equal to 2, or we're going to make that first one's denominator work out for the restrictions. And the common denominator is x and x minus 2, because that's the only thing that's in all of them. So if you do x and x minus 2 times this one, x and x minus 2 times this one, and x and x minus 2 times this one, to see what will be left when we cancel. Well, if I cancel both of those, I only have a 10. If I cancel the x, then I'm going to go 4 times the parentheses is 4x minus 8. If I cancel the parentheses, I'm just going to have a 5x. So finally we get a chance to see one that doesn't have any powers in it. So when it doesn't have powers in it, you want to put your terms together on each side so that you can simplify it, and then move all your x's to one side. Now normally I don't go to the right, but this problem's not that bad. Take 4 away from 5 and you only have 1 x left, and that's the solution. But look what happened. I got the number that was supposed to be for the restrictions, so this problem has no solutions, because the one solution I could have is what made the denominator 0, so therefore it can't be a solution. Alright, let's look at another one. So in this one we have x minus 2, x plus 2, so that's going to be our least common denominator. Our restrictions are going to say x cannot be equal to plus or minus 2, because that's what makes those two 0. So when I put this least common denominator of x minus 2x plus 2 times each one, some of them will eventually cancel out. So I have x minus 2x plus 2 times this one, x minus 2 x plus 2 times this one, and x minus 2 x plus 2 times this one. So let's see what cancels. In this one, the plus one cancels, so I'm going to distribute that and get 2x squared minus 4x. And this one, everything cancels, so I have a 1. And in this one, I'm going to multiply them together and get x squared minus 4. So I have quadratics on both sides. So let's take x squared away from both sides. And that leaves me with 2 linear terms over here, so I'm going to put that together. Well, I might as well move that over also, because I didn't get rid of the quadratics, so it's got to be equal to 0. And factor. Again, this is one of those that doesn't start with a 1. So 2 times 3 is 6. Is it 1 and 6 or 2 and 3? It's got to add up to 4. If I did that right. Neither one of those do. So let me double check my math. Or that I wrote the problem down correctly. Let me pause this video and double check that. Okay, I need to go back up here. I made a mistake right here. And that's what you'll have to do sometimes. You'll have to go through and find your mistakes. 2 minus 1 is not 2, it's 1. So then when I bring over my 3 and add it to the other side, I don't need the list to do this one. It's x minus 3 and x minus 1. So x can be equal to 3 or 1. Look at my restrictions. My restrictions are negative 2 and positive 2. That's not what I've got here. So those restrictions do not make the denominator 0. I mean, these solutions don't, so they are actually the solutions. With this one, you would have to take a 2 out of this one so you can see that x plus 2 matches up with the other one. So when x plus 2 is set equal to 0, you get x equal to negative 2. If you take 3x squared plus 2 and set it equal to 0, you get 3x squared equals negative 2. When you divide by 3, you get x squared equals negative 2 over 3. When you square root that, it's imaginary, so that's not going to be a restriction. Alright, now least common multiple of this problem. Well, first of all, you got a monomial 2, then you got an x plus 2, then you got a 3x squared plus 2, so that's going to be your least common denominator because you need all 3. So we're going to multiply 2 times x plus 2 times 3x squared plus 2. Then we're going to multiply 2 times x plus 2 times 3x squared plus 2, I'll times that one. And then over here we're going to do 2 times x plus 2 times 3x squared plus 2 times that one. Let's see what cancels. In this one, these two cancel, so I just need to distribute 8 to that parentheses, which will give me 24x squared plus 16. In the middle here, these two cancel, so I'm going to take and make that plus a negative so I can distribute my 2 as I go and get negative 2x minus 4. And over here, the x plus 2's cancel, so I'm going to distribute 4 and get 12x squared plus 8. Because 2 times 2 is 4 up there, I can distribute both monomials at the same time. So now let's move everything to one side by taking 12x squared away and minus 8 away. So 24 minus 12 is 12, x squared. I only have one linear term, so minus 2x. But I have 16 minus 4 minus 8. So 16 minus 4 is 12, and minus 8 is positive 4. Now, I look at this and I think, well, you know, that's probably going to factor because I can take a 2 out. 6x squared minus x plus 2. And I got to figure out the pattern. Now, that 2 is not going to have anything to do with it, so 6 times 2 on the end is 12. 1 and 12, 2 and 6, 3 and 4. They both got to be positive. Well, I must have made another math error because I don't believe that's the answer, but let me double check it. Hold on just a moment. Okay, I found my error. Sometimes when you're working these problems out, you got to be so careful, and I should have took more time to write this one down. Let me explain why. When I was working on this middle term up here, I had all 3 of these multiplied together, and I didn't see that middle one, so that messed up my middle right here. I got to multiply the 2 parentheses together and then multiply it by negative 2. So multiplying the parentheses together would give me 3x squared plus 6x plus x plus 2. And then when I do negative 2 times it, it'd be negative 6x squared minus 12x minus 2x minus 4. Alright, so now when I take my terms and put them where they were, let's re-add it and see what we got. We got 12 minus 6 is 6x squared. I have linears now of 12 and negative 2, which makes negative 14x. I have that still was going to be the right answer, 4. So it changed a lot of my problem now, so when I take my 2 out, maybe it'll factor better this time. So I still need my list. 2 times 6, 3 is negative 6. So that's 1 and 6 or 2 and 3. And it's got to make negative 7. Oh, it's positive 7. It's going to make positive 7 when it multiplies to be positive 6. So that's this one. So 3x squared minus 6x minus 1x plus 2. Split the problem. 3x can come out, leaving me with x minus 2. And I can take a negative 1 over here and get x minus 2. So 3x minus 1 and x minus 2. X is going to be 1/3 and x is going to be 2 if you set those equal to 0 and solve. Those are not my restrictions. So since they are not my restrictions, they are perfectly good solutions. It's a good thing it didn't come out negative 2, because that's the one number it can't be, right? It couldn't be negative 2, but it came out positive 2. It couldn't be imaginary, and it came out positive 1/3, so we're good. So, as you can see, these can be a little complicated, and even I once in a while make a mistake, especially if I'm in a hurry trying to finish a video before somebody comes to ask questions. So you need to slow down. I would suggest you rewrite each fraction and do what I did earlier, because that one I didn't do it on, and that's why I made that mistake. You really need to do it more like what I did here, where I took the first problem and I rewrote it and put those next to each one, because this process right here is very important and makes it easier to see what cancels and what you're multiplying together. So now you'll be able to finish worksheet homework 0.4, which is in Canvas.